Okay guys, in this video we're going to recap what we know about the concept of work or physical work. And so really quickly, let's go ahead and write down our definition of work here. But the definition of work is this. We say a force vector with a given direction here times a distance. Okay, so a force over a distance, where we say that this is the force moving in the same direction as the distance. So moving in the same direction as the distance. So in terms of what we tend to see here, I suppose if we had a mass that was on the ground here and we knew how much force was going in this direction here and we knew a distance, okay, a distance here, we could just take the product of this distance here with this force. And so the thing here that is a little bit awkward is that we're not always pulling in the same direction as the force that we're given here. And so I certainly will take this force that you see here times the distance, but let's imagine that really what I'm doing here is that I'm pulling with this force here. We'll call this force 1. And so this force that I'm pulling at here actually has some angle that it's making with the horizontal here, but also has components here. We'll call this force 2 here. And so what I can tell you is force 1, at least as I've drawn it, is equal to the initial horizontal force here plus this force 2. And so adding these two components together, what I want you to see is that a lot of the time what we're going to be doing is just really using the horizontal component that we see here, multiply it by the distance, because even though we're pulling at an angle, this is the component of force that's going in the same direction as this distance that you see here. So with respect to the problems that I'll have you look at with me here, let's take a look really quickly here at 78. 78 says determine the amount of work done by a crane lifting a 2,400-pound car 5 feet. Well, here's the deal. This is our 2,400-pound car that is, it's kind of this vector right here, and we're lifting it 5 feet. And so if what I'm doing is I'm lifting this, a distance of 5 feet, and the force vector here is 2,400 pounds, then really all I'm going to do is say that the amount of work that I'm doing here is equal to the 2,400 pounds, which is the amount of force going in the same direction as this difference in distance times 5 feet. And so what we end up with is this, I suppose, 12,000 foot-pounds worth of work here. And so 12,000 foot-pounds is our work here, but because we took the force that is in the direction of the distance we're traveling times the distance that we're traveling. Now when we look at, say, something like number 79, this is a little bit different this time. It says that a force of 45 pounds exerted at an angle of 30 degrees with the horizontal is required to slide a table across a floor. So determine the work done in sliding the table 20 feet. Well, here's what I'm going to do. I'm going to go ahead and draw my table here, and I'm kind of boring with my objects. I just draw kind of a mass this way. But we know that this is the force vector that is doing the work right here. And in terms of the angle that it's making with this horizontal right here, we say that this angle in this case is given as being looks like on number 79 there 30 degrees. And so 30 degrees, and we know the magnitude of our force here is 45 pounds. The only thing else that we would need to know here is the amount of distance. And so in this case, the distance that we're traveling here is 20 feet. Okay. So in terms of what we're going to be doing, let me switch colors on you here, but essentially we're going to be taking this component of force right here, and we are going to multiply it by this distance. Now in terms of what is this component of force that you see right here, recall that this component of force would be given as the magnitude of our hypotenuse here times the cosine of the direction angle. And so in terms of work, we're going to take our distance, 20 feet, but we're going to multiply that by the magnitude of our force, 45, times the cosine of the direction angle, 30 degrees, and this is in pounds here. Essentially where this is going to give us a decimal, but this is going to be our work value here. So here's where we'll just need to grab our calculator and say we're going to take this distance, 20 feet, and we're going to multiply it by the component of force that's going in just the horizontal direction or in the same direction as the distance here, which is this 45 cosine 30 degrees, and making sure I'm in degrees here. But we get 779.4, and so that's what I'm going to write. I'm going to say 779.4, but the icing on the cake here is that we need to label with units. So in this case, we're going to have foot-pounds of force, and we have approaching 800 foot-pounds of force being done in that direction. Cheers.